vibration in horizontal mode for the following portal frame. Full stop. Assume the girder is infinitely rigid. Assume the girder is infinitely rigid. So problem from audio parts, span of the beam and height of column they are given in feet, 15 feet. So 4.57 feet. Width of the beam is this much. Moment of inertia of the beam is quite large, infinitely rigid. And moment of inertia of the column is we have to find out the natural period of vibration E of this frame when it is vibrating in the horizontal mode. Due to some initial conditions, maybe. So before that, we have to find omega. So under root K upon M. Where K must be unit. I told you yesterday. Newton per meter. Whatever your units are converted, then only you will get omega correct. Well, let us get the mass first. Mass is equal to W upon G because W is equal to mg. Convert W in Newton first, divide by G, and tell me the mass. Yes, what is the mass?
11345.
11345.
11345.781.
781 kg. Is it? When we discussed elastic forces, we have derived expression for stiffness of this frame with both ends fixed and girder infinitely rigid. See the discussion on elastic forces. The complete procedure also, read it once. What's the value of K? Yes. That is for the actually loaded rod. For total frame. 24 EI upon H cube. See how we are derived it. We have used a simple concept of a fixed beam whose both ends are fixed. See that the girder is infinitely rigid. Slope at the bottom is 0 because it is fixed. Slope at the top will also be 0 because the girder is very deep. It will not allow this column to rotate. It will just allow the column to deform without rotation. And that's why moment at the top and bottom of the column is 6 EI delta on H square. And then we have found shear force 12 EI delta upon H cube. And the total lateral force is 12 plus 12, 24 EI upon H cube. And that's how the stiffness is 24 EI upon H cube. Right? Now substitute. So everything in proper unit and then we K in inverse form.
So is it 2.57 meters?
4.57
Span.
span 4.57 meters. Yes. 15 feet as I said. So 4.57 meters. If it is not given, you can assume 2 into 10 raised to 5 megapascal steel frame. Yes, what's the value of K? Somebody is ready. K take everything in Newton and mm. So is 24 is look at this to 5 Newton per meter square. So you can say 2 Newton this to 11 Newton per meter square. I is 84 centimeters to 4. So then there's 2 minus 8. Because converting centimeter to meter, then there's 2 minus 2. And it is centimeter raised to 4, so minus 8 divided by so simple. It is why you are taking so much time. Yes. 4 and we as many digits as possible. 4.216. 4 more digits. You can just do 6 Newton per meter. As everything is in Newton and meter. We say this is equation 1. Substituting in equation 1, you will get over.
$90.277.
19.277. Very interesting. We are interested in period of formation T. This is equal to 2 pi upon 5.
$1.325 to 26.
326 units. Second. Sure, you can get F. Is equal to 1 upon T.
3.068.
3.068 hertz or cycles per second. That's the complete problem of a total flame. When you take some assignment problems, today I'm going to check on the discouraged problems. The next question number 7. Okay. Same question you repeat. This question, I just make some small change. The space is huge. So what will change? Only K will change. So please work out K for this frame. Well, right hand side column, both ends are fixed. So moment at top and bottom is yes, 6 here at the on H2. Let's call it M. The column is rotated in the clockwise sense. Both the moments are anti-clockwise. And the shear force is V. If you take moment at the base, M plus M, 2M, but take anti-clockwise negative, then moment of V is positive, so this V into H is equal to 2. And therefore V is equal to 2M upon H. And that's how it is. So we get the upon H2. At least on this problem. The condition of right hand side column is base is hinged. When it deforms, as the beam is rigid, top is not going to rotate. Rotation at top is 0. But rotation at the base is present because it is hinged. What is the moment developed at the top? When both ends are fixed, it is 6 yard and upon H square. That's okay. But one end is hinged. You can refer topic of moment distribution method. There you will get. It's easy to work out. You can look at this column like this. If I take both ends are fixed, moment at top and bottom is anti-clockwise. Agree? But now actually base is hinged. So I have to make this moment 0. And to make this moment 0, I have to apply equal and opposite momentum. Momentum in clockwise direction. Half of the moment will be carried over on the top, m by 2. And now what is the net moment at base? 0. Because I have balanced it. To make it 0, I have applied anti-clockwise momentum. No? And what is the net moment on top now? N by 2 anti-clockwise. Sorry, M anti-clockwise. And M by 2 clockwise. So it is M minus M by 2. How much is? M by 2. And that M by 2 will be anti-clockwise. And that's how this moment is not 6 ER delta upon H12, but it is 3 ER delta upon H12. And now you can work out the shear force in the same way. Moment here is 0. Moment here is 1 by 2. Anti-clockwise. Take moment of all the forces at the base. And call it V1. This will be V1. So minus m by 2 plus v1 into h is equal to 0. Therefore, v1 is m by 2h m by 2 is 3 and delta on h1, so it is h2. Value of m by 2 is 3 and delta on h1. Both again divided by 2. Value of m by 2 is 3 and delta on h1. So here the shear force is V, 12 ER delta upon H2. Here the shear force is V1. Apply force P here. I can say P is equal to, let me call this as V2. P is equal to V1 plus V2. So it is 3 ER delta upon H2 plus 12 ER delta upon H2. Is it? And that's what P is equal to 12 plus 3, 15. ER delta upon H2. And therefore, stiffness K of this frame is 15 ER upon H2. Now it is not 24. So one very important conclusion as a structural engineer you can draw from this discussion, just by changing the support condition, stiffness of the frame is changed. It is reduced tremendously. Right? Okay. And now you can find omega. If K is reduced, omega will be reduced. And if omega is reduced, period will increase. Because T is equal to 2 pi upon omega. You can do it at home. And submit this as assignment. Take one more problem. Write the same problem. So make both ends switch. Now you should be in a position to tell me stiffness quickly. Yes. 3 at delta upon h square moment here. Similarly, 3 at delta upon h square moment here. Shear force will be 3 at delta upon h cube. 3 plus 3 will be 6. So, right, K is equal to delta upon h cube. Take one more problem. Because the column is H, this column, and this I'll take 2H. But both the bases are fixed. Now you should be in a position to find K quickly. moment on the left column is CN delta upon H square. And moment on the right side column is 6CN delta upon, you can say H2 square. Whatever is the height of that column, H2 square. And now substitute H2. H2 is twice H. So twice H square. Rest of the things are same. You can find out V1, you can find out V2. E is equal to V1 plus V2. Agree? So you can do it at home and show me on Saturday these problems that I am giving. Any doubt? Any doubt? Please be frank to ask. Well, up till now we were discussing linear vibrations. Whether it is beam or frame, we have discussed linear vertical vibration, linear horizontal vibration. Now let us discuss angular vibrations. So you can give a title, angular vibrations. So let's directly take a problem. Derive the governing differential equation of oscillation of a simple pendulum and obtained its solution. Full stop. Assume small oscillation. किंवा तिथे लावलं तरी चालेल. ठीक आहे, लेक्चर झाल्यावर लाव. ते बोर्डच्या सेंटरला लाव, बरोबर. बोर्डच्या सेंटरला वरती लाव. Assume small oscillation. ठीक है. Let's consider a simple pendulum. Of mass m. Say the length of the string up to the center of pendulum is L. said any instant of time, I can define position of the system with an angular displacement theta. It's not linear displacement now. It is theta and radian. Now let's mark all the forces acting on the pendulum. First of all, its weight, W is equal to mg. You can resolve the weight along the string and perpendicular to the string. What is this component? Along the string. If this angle is theta, made by string with the vertical, naturally this angle should be theta. So what will be this component? Masters, sin theta. If there is a force there, what is the x component? Cos theta. If you are measuring x, rather if you are measuring theta from x, that component will be cos theta. So adjacent component is always cos theta. So it is mg cos theta. You have to revise a lot of basics. What is this component? Now the component away from theta is mg sin. If I assume the pendulum is still going towards left with an acceleration A, there is one more force, that is inertia force, which is always mass into linear acceleration A. Mass into linear acceleration A. Well, for completeness, there will be tension in the string T. Tension in the string T. If I resolve all the forces perpendicular to the string, so you can say resolving all the forces perpendicular to the string, comma, for equilibrium, there are two forces, Ma plus mg sin theta is equal to 0. That's how I get the equation. And we'll get cancelled. Where A is linear acceleration. Let's say where A is linear acceleration and theta is angular displacement and theta is angular displacement. So let me see if I can convert linear acceleration also into angular acceleration, so that I will get equation in terms of only one variable theta. See, for any circle, say R is radius and theta is the angle. S is equal to R theta. Simple equation. The length of the arc is radius of curvature into the angle theta. If I take derivative of this equation with respect to time, what is S? Length of the arc. If I take its derivative with respect to time, it is velocity. Ds by dt is equal to R into d theta by dt. And d theta by dt is the angular velocity omega. So V is equal to R omega. Okay. If I take its derivative further, the derivative of linear velocity is linear acceleration A. dv by dt is A, am I right? Is equal to R into d omega by dt. And d omega by dt is the rate of change of angular velocity, that is angular acceleration alpha. See here, omega is d theta by dt. If I take derivative of omega, I can say it is d square by dt alpha. So R into theta divided. Angular acceleration is nothing but second derivative of angular displacement. Omega is theta naught. Here also you can write is equal to R into theta naught. What is R in this case?
Yes.
L. Yes. And therefore I can say A is equal to L into theta plus G sin theta is equal to 0. This is the governing differential equation. Is it? Let me call this equation 1. You can say this is the governing differential equation. See, this equation has got sin theta, and sin theta is a curve. It's not linear, it's non-linear. So this is a non-linear differential equation. So you can say it's a non-linear differential equation. You have to convert a non-linear differential equation to linear differential equation. How you can convert? There is one small sentence I given in the question. Read it. Normally in M.Tech. But that is the case. Assume small displacement. So you can say assuming small displacement. Assuming small displacement. See, displacement is very, very small. Sin theta is approximately equal to what? If theta is very small, sin theta will be 0. Sin theta is 0. And theta double dot will be 0. Everything has gone. Take out your calculators. Go to radian mode. Find out sine 0.01. If I take theta in radian, 0.01 radian, sine of 0.01. How much it is? Yes. How much it is? 10 into 10 raised to minus 3. So it is 10 divided by 10 raised to 3. So it is 1 divided by 100. So it is 0.11 again. So what is the conclusion? So sin theta is equal to theta. In radian. What in degrees? I think you have made this assumption many times. Sin theta is equal to theta, but you have never tried on calculator. नाही ना? कोण सांगितलंच नाही का? आम्ही तरी काय करणार? आमचा काय दोष आहे सर? But see, nobody told this to me also as a student. I tried here. Teachers are saying many times sin theta is equal to theta. Let me work out. I tried in degrees first. काय sir काहीतरी बोलतायत. And then we thought why not to try in radian, because many times when there are angles we put in radian. Let us try in degrees. Let's try in degrees. Sine of 0.01 point 1.74 into minus 4. So it is not matching. It's not matching. So in radian, definitely you will get sin theta is approximately equal to theta. If I substitute that, I get L theta plus G theta is equal to 0. Calculator is of best help to you. Make use whenever there is some such discussion. Try to find out on the calculator if it is there. Now there is no non-linear term. Everything is linear, so you can say this is the governing differential equation of oscillation of a simple pendulum which is linear. Which is linear. Now compare this equation with the equation of linear vibrations. So you can say comparing this differential equation with the differential equation of linear vibration,
whatever plus K1 is equal to 0.
for this equation I know omega is equal to root K upon N. And the solution of this equation is y is equal to A cos omega t plus B sin omega t. So omega for this I can write omega is equal to root. At place of M, I have got L, and at place of K, I got G. So it is G upon L. And solution I can write theta is equal to A cos omega t plus B sin omega. Is it? If you want, you can write the equation of period t is equal to 2 pi upon omega. So it is 2 pi equal to L upon G. I think this equation you might have used in your 11th standard. Period of oscillation of a pendulum. 2 pi under root L upon G. And if you want, you can write 1 upon T. Full stop. You can write on the next line, if this pendulum is given an initial angular displacement at t is equal to 0, theta is theta 0. Only no initial angular velocity, only angular displacement. You will get a is equal to theta 0. Check it. Substitute at t is equal to 0, theta is theta 0. You will get a is equal to theta 0. And if you take the derivative of this equation, you will get b is equal to 0. And the equation of theta will be theta 0 cos omega. Plot the graph of angular displacement theta versus time. It's a cosine curve. At t is equal to 0, theta is theta 0. Okay. What's the time now? 1:30. We'll stop here for today. Of course, I'll check the assignments. Number 1, third, is there online? No. Row number 2, Kurgaonkar.
Yes, sir.
Okay. Row number 3 is Satpute. Satpute is there? No. 4, Sigat is there. 5, Shishi. Okay. 6, Gore is there online?
Yes, sir.
Okay.
Yes, sir.
Anjali is there. 8, Kapat is there. Inamdar. Roll number 9.
एक 2 मिनिट अजून प्रिंट घेऊन येतो. प्रिंट घेऊन येतो.
Roll number 10, Sayyed.
Yes, sir. Present.
Okay. 11, Pawar. 12, Band. 13, Sasne. Okay, we'll stop here for today. I'll check the assignment tomorrow. Take a few more questions for assignment.